All right, this lesson is about graphing rational functions, specifically a rational function when the numerator and denominator are both linear functions. And the one we're going to look at will be y equals 3x minus 6 over x plus 2. Now, what you hopefully notice as you look at this, when you focus on the denominator, remembering that division by 0 is undefined allows us to state our domain. So our domain becomes all real numbers except -2. And we can write that in interval notation, and we can write that in set builder notation, or we can just express it as we have in relatively simple English. Now, as far as the range is concerned, you want to focus on the leading coefficients. Now, in this case, we're talking about 3 over 1. And so my range is all real numbers except 3. Now, the idea there being that the numerator, no matter how large x gets, will always be roughly 3 times the size of the denominator, but never exactly 3 times the size. We can investigate that with our trusty calculator here. So we'll create a new document and a calculator page, and let's define that function. So give ourselves the fraction template, 3x minus 6 over x plus 2. And we'll save that, so store it as function 1 of x. All right, so that's done for us. And we can again use this to evaluate the function now for various values of x. We can do simple values like f1 of 0 is -3, but we can also investigate what happens as x gets bigger and bigger and bigger. So f1 of 10 is 2, but the function evaluated at 100. Now again, think about that. That's going to be 294 divided by 102. Now, seeing that as 49/17 doesn't help us a whole lot. Let's look at that as a fraction. There it is in fraction form. And then f1 of 1,000. Control Enter. 2.988. And then how about 10,000? Again, with the fraction by accident, but there you are in decimal form. All right, so 2.9988. As we continue to let x get larger and larger and larger, the function value will get closer and closer and closer to 3. This is actually an idea in calculus. We would say the limit of f of x as x approaches infinity is 3. But in Algebra 2, we simply say that the range is all real numbers except 3, but that also dictates that we're going to have a horizontal asymptote. So the horizontal asymptote is y equals 3. In a similar fashion, back when we're talking about our domain, our vertical asymptote is all real numbers. I'm sorry, our vertical asymptote is simply x equals -2. It's our domain that's all reals except -2. Mr. Glover walked by and distracted me there. All right, so we have our asymptote set up. We understand our domain and range. At this point, it's time to create the graph. All right, so let's get a new page where it won't be quite as cluttered. All right. And let's go with a bigger graph. That one works well. All right, so just to remind ourselves about what's going on, we've got y equals 3x minus 6 over x plus 2. Again, our domain was all reals except negative 2. Well, that's going to force us to have a vertical asymptote at x equals negative 2. And we'll mark that with a broken line. And again, x equals negative 2 is our vertical asymptote. And we had our horizontal at y equals 3. That's our horizontal asymptote. Now what we're basically doing is making t-charts, plugging numbers in, evaluating the function, and plotting the dots. And in this case, we really have two, one for the left branch, which will use values to the left of our vertical. So numbers like negative 3, negative 4, negative 5, and so on. And another for the right branch, which will use values to the right of negative 2, like negative 1, 0, 1, 2, 3, and so on. And at this point, we are simply plugging numbers in and seeing what we get. All right, so for our left branch, here, we'll go ahead and do that one in blue. If we plug in negative 3, well, the numerator becomes negative 9 minus 6, which is negative 15. The denominator would be negative 3 plus 2. That's negative 1. And a negative divided by a negative is a positive. So our first dot, we would try to place at negative 315. That's clearly off of our chart. So we'll move on to negative 4 and see if that works for us. Negative 4 gives us negative 18 divided by negative 2. That's 9. And we have a dot we can locate. So negative 4, 9 is our first dot. Negative 5 would be negative 21 over negative 3. That's 7. We'll place a dot at negative 5, 7. Negative 6, negative 24 over negative 4 is 6. So we have a dot. Negative 7. Looks like we're going to get a decimal value here. We got negative 21 minus 6 is negative 27. Negative 27 over negative 5 is 5 2/5, or 5.4. So 5.4 is right about there. Negative 8. Let's see, negative 24, negative 30 over negative 6 is 5. And that's probably enough. I'm afraid negative 9 is another decimal that I'd prefer to avoid. But from those dots, hopefully you can see the general shape and you can connect them. Now, all of the graphs that we make by hand are going to be estimations, but hopefully semi-accurate ones. Now you could exploit the whole symmetric concept to graph the other branch at this point, or we can go back to the plug and chug. All right, negative 1 gives us negative 9 over 1. That's negative 9. So negative 1, negative 9. We have a dot. All right, and that dot would actually be symmetric with the dot we didn't plot up at negative 315. 0 is easy. Finally, an easy one. Negative 6 divided by 2 is negative 3. So there's our dot. 1, not too bad. That's negative 3 divided by positive 3. That's negative 1. This side is a lot easier. 2, short and sweet, gives us 0. 3, 9 minus 6 is 3. 3 plus 2 is 5, so 3/5. Which is 0.6, again, if you prefer decimals. So just above a half. 4, 6 divided by 6 is 1. And again, that should be sufficient for us to get a look at what we have in terms of the basic shape of the graph. But that's it. Determine your domain and your range. From them, you'll get your asymptotes. The asymptotes will lead you to your charts. Your charts will lead you to your graph. And then you can, of course, verify this with your calculator. Well, we'd already saved that as function 1. Let's see if that shows up as a graph. Add a graph. How about function 2 equals? Let's try to put function 1 there and see what happens. Of x. There we go. We have it done. So, slightly different window than what we had before, but basically the same idea. So, hopefully that helps. And again, the other thing you can do with these calculators, remember Control-T will give you your table. And so we can scroll through this table and see all of the values that we've been working with. And of course, at -2, as you can see, the function is undefined because division by 0 is undefined. Remember, that's a little different from indeterminate, but that's a lesson for another day. Thanks.